So my name is Mark Aktimachuk. I'm a performance specialist at VMware, and that puts me on the pre-sales side of the organization. I'm the only performance specialist from North America, so I get to roam around with the biggest set of clients out there, dealing with issues that are seen in the field, evangelizing performance. And today, in the discussion here, I wanted to bring up the salient points, the important stuff around performance that I see and continually see all the time. So some of it may look like it's repetitive. You may laugh at a couple of the things I highlight, but please do remember, even the best of the best still get caught on some of this. And I have with me my peer, Reza. I'll let you do an introduction.
Hi, I'm Reza Tahiri. I've been with VMware for a little over 4 years. And before that, I was with Bell Labs and then with HP for 20 years. I focused all along on optimizing the performance of high-end servers and in particular database applications. And what I'm going to talk about today is some of the specific Tier 1 applications that we have been focusing on and what their performance looks like.
So quickly, you guys have probably seen the disclaimer, not going to pound it into the ground. It doesn't kind of really apply. We have no secrets in our presentation. This is real-life data we want to share with you. And again, to kind of reiterate the agenda, so I want to dive into each of the resource dimensions quickly and talk about what I think are the key design points to remember, the considerations to make. And then I'm going to hand it off to Reza, who will actually, let's go through some of the data that we've collected on the vSphere 5 platform. So as we continue to go down this virtualization journey here, you guys have seen a lot of this data probably, which is the fact that we continue to scale our platform. We continue to scale the size of the VMs. And we continue to look at all four of the resource dimensions, being CPU, memory, network, and storage. And with the vSphere 5 release, this is the piece that gets me pretty excited because under 4.1, I have seen organizations virtualize, 90%, 99% to 100%. So when those say you can't get there, we actually can. And now with the vSphere 5 release, the numbers are just through the roof. And I just want to highlight two of them quickly because, in my mind, again, very important. We're not worried about compute anymore. We're not really worried about memory that much anymore. But what is important is the I/O, both on the network side and the storage side. And so I highlight here again, like we saw at the big release, 1 million IOPS out of a single ESX host. And I do want to call out this number quickly because a lot of people will say, oh, it's benchmarking. You used little tricks like 512 byte. Read blocks or something like that, and it's not. It was actually done with a single Vmax. It was done using an 8K block, and so again, real life numbers here. And as I kind of talked about the four resource dimensions, I throw this graphic up here because again, I want to assure the crowd that when we look at a design, when you look at building out your environments, you want to make sure you're still continuing to address the four dimensions. We still need to pay attention to what we're doing for network and storage. We have a bunch of guest set of drivers there, platform design considerations, we'll touch on them. But again, always look at it holistically. Always address all four because they're an important part, right? Weakest part of the chain is always the weakest link. So let's look at compute. So what's most important in this space, in my mind, is basically processors that support this hardware MMU functionality, or hardware memory management unit. And this in the Intel space is the Nehalem chipsets or later, and in the AMD space, Shanghai or later. And again, to reference the feature set EPT and RVI. Now why this is, in my mind, critically important as we push that journey to 100% is these big Tier 1 applications, these big databases, these big messaging systems are using memory. And we want to make sure that we have the best processor that's going to help us do that memory management. The hardware MMU allows us to offload memory interaction to a hardware instruction set. When we map guest memory to physical memory, we used to do that in a software table. We had to do it at software type speeds. Now we can actually offload some of that to the processor functionality here. And that just completely alleviates, memory as a worry or as a concern. So now we got fast processors and fast memory. Where this comes out is people continually miss this as they're refreshing their environments. They're taking a big application. They're saying, hey, Mr. Corporation, I can do my exchange, and I'm going to put it on this box, and I didn't check if it had hardware MMU. Maybe it's a little bit older, it was one that got freed up from the lab, and we're missing this feature. And without this feature, you will feel the difference. So some other considerations for compute. Definitively, let's make sure we continue to leave NUMA on the server platforms. Hyper-threading on the server platforms. Turbo mode on the platforms. So you'll see and hear a bunch of confusing stories out there, mixed messages, something that might be slightly outdated. But again, let's make sure this is where we kind of draw the line to support it. Power management. Anybody who's heard me speak before, you might even have heard me say turn power management off. I'm turning a leaf over. We can leave power management on nowadays today. That's good. With one minor exception, which is if you're working with a really sensitive, latency-sensitive application, potentially like a VoIP, big financial trading systems, we may still want to shut that off. There's a small difference in that use case. But otherwise, feel free to support that appropriately, leave that on, get that power savings if you want. And size the compute platform. So I highlight here, when we build VMs that are 8-way or larger, up to 32 now, let's not put them on a 2-socket system. And everybody will laugh, but I see that quite regularly. The bigger VMs we create, the bigger the platform we need to support them. So my rough rule of thumb was if you build bigger than 8, make sure it's on a quad socket or larger platform. And I call it here vSphere 4.1 or newer. 4.1 had a lot of scheduling enhancements and went the extra mile with a bunch of optimizations for performance. So please be looking at making sure your platforms are at least 4.1 today. And as you'll see a little bit later on, the numbers for 5 just completely come off the top. So memory. What do we need to worry about in the memory space here? So quickly, let's review what happens when we look at overcommitting the host memory. Remember that we're going to do transparent page sharing, or TPS, first. Remember that once we can't alleviate pressure with TPS, we're going to start to balloon. Remember, when we can't balloon, we're going to start to compress. So that's the last-ditch attempt to, again, keep those memory pages on the memory sticks. vSphere 5, we introduced a new technology called swap-to-host cache. Here, again, what we're doing, and before we put that memory page to swap and put it on rotating media, we're going to actually put it on SSD now. Because, again, much, much quicker. So I want to assure everybody that, yes, in these big designs, when we're looking at maximum performance, you can overcommit host memory. You can do it performantly because you have all these technologies in place, and we continue to develop them. So don't be fearful of that. Memory speed, I get kind of the question, should I be balancing it out? What happens if I put more memory in and I drop, the bus, frontside bus to 800 megahertz or something like that? Know that that is relatively insignificant. Know that I would choose personally to have more memory than short amount of memory that are quicker. Now, there are very tactical use cases where memory speed can make a difference. But let me tell you, that's probably the 3%, the 5% rule. Again, I always adhere to, you want to make sure you have more than, again, fast. Make sure that we're balancing that out. As we're building these servers, we're balancing the memory sticks amongst the NUMA nodes. Make sure that when we're looking at Tier 1 applications, we're looking at things like memory reservations. That's an important thing. And you'll notice that in any of our database white papers, you're putting a memory reservation in for the full allocated amount. And here's a little tip trick that I continue to see in the field that way. We want to make sure that hardware MMU functionality is on. And it'll look like it's on, but unfortunately you have to go into the log files to confirm it. So if you go into the VMware.log file for the specific VM and you open it up and you search for a line that says virtual MMU, you want to make sure that it says hardware and not software. And I particularly point this out for AMD because in the past, our software MMU could outrun the original editions of hardware MMU on the AMD platform. So our monitor mode sometimes will default to using the software. So always jump in here and always double check because it's nearly a 30% performance boost like that when you can enable that functionality. So just triple check that. Network considerations. Out of all of my time in the field, and for how many times we in IT have blamed the network, the black box, it's the network's fault, it is extremely rare to be the network issue in the virtualization stack. As long as we look in consideration for design, our uplink teaming policies. We have a bunch to choose from. We have obviously route-based on virtual port ID. We have load balancing. We have IP hash. We have MAC hash. And so when we look at designing out the platform, pick the right one that's appropriate. Now, everybody's going to throw up their hand and say, oh, Mark, IP hash, right? That's how I'm aggregating links. I'll be honest, I rarely would use that one. I actually use the load-based teaming policy instead. There's a few minor exceptions where we can actually get additional throughput using IP hash, but it's not worth the complexity of configuring on your switch side and worrying about it. So like I said, by default, that's a pretty easy one. Use network I/O control. That's what that engine's about. I continue to talk to clients who aren't turning that on. They're fearful of it. They're not sure about it. Use that. That's going to help guarantee predictable performance for your Tier 1 applications. Guarantee bandwidth to your particular applications. Make sure that vMotion doesn't stomp the performance of your applications. So get to know that feature very well. I still like to break out storage networks. If you're using, NFS that way, iSCSI, I will traditionally break them out so that we have front-side client networks and storage networks still. Make sure that vMotion here, you're planning for bandwidth. Everybody got all excited when we released the Monster VM, but think about pushing a terabyte of memory across the network. Can you do that over a gig link? No. Can you do it over a 10 gig link? Yep. Can you do it over many 10 gig links? Even better yet. But let's remember, as you continue to build up those VMs, don't forget that you're creating something bigger, and we should have planned for that in design to vMotion those around. And another little one here, interrupt coalescing is enabled by default in the network stack. And for applications that, again, latency sensitive, I look at the VoIPs, high transaction-based systems, we want to disable that. And again, I say evaluate it and try it to make sure, but this will actually, it's a bit of a trade-off here. We're incurring a little bit of latency for a little bit more throughput. Those applications we want very low latencies, and we'll trade off potentially a little throughput for it. And storage. This is the evilest guy in the stack here. So if you guys take nothing away, besides the great information Rez is going to talk about, make sure you focus on storage. That is my biggest problem I see in the field. That's the one that I want to make sure you guys take away, are aware of, and are focused on. Because it looks complicated, doesn't it? When we go from spindles at the bottom to virtual disks at the top. We want to make sure that we have enough spindles behind things. We want to make sure if we can use features like VAAI to offload some of that, we do. We want to make sure as we aggregate these data stores together, we're doing it appropriately, we're striping appropriately, we're using multi-pathing, preferably. Round robin is the secondary option. Right? Now, remember, round robin is not multi-pathing. Round robin is dropping IOs into this path, into this path, into this path, and back again. So by turning that on, yes, some arrays, it looks like you're going to get faster because we're bottlenecking on a path. But no, it's not true multipathing. And as we continue to roll up the stack here, other considerations too. So the virtual machine layer, we still need to think about alignment, especially for all that old stuff. We need to think about things like snapshots. Because snapshots are great. They're very powerful. We use them all for backups. But we should not be snapshotting a database and leaving that in place while we run it. That will incur a performance penalty. So we need to look at this holistically, right from the spindles to right to what we're connecting at the VM. And for many in the room here, by show of hands, who here controls the storage and the VMware silo? Well, that's pretty good. I'd say we've got a good solid third out there. But for everybody else, you have to talk to a peer. You need to bridge that guy in. You got to break down that silo. You guys aren't enemies anymore. That's the first thing I need to do on the phone quite a bit. So make sure that you guys can speak some of that language, and they in turn understand some of the VMware language. If you focus on this, you're guaranteed performance success. If it's not working out, you call me, and I'll help you with it. That's the deal. So what's important in the stack? I'm going to point out two indicators here. When we look at the bottom, labeled on the diagram here is D. I call that device average latency. I don't call it that. Everybody does. This is the measure of latency from the moment the I/O goes into the device driver out across your fabric to your array, and that acknowledgement comes back. That is a very important latency number to know. That's going to tell you how fast the storage subsystem is. Further up the stack here, labeled K, is what we designate the kernel average latency. This is how much time the I/O is taking to pass through our hypervisor. And this happens in microseconds, tens of microseconds, and at worst case, hundreds of microseconds. So you want to know how much overhead we add? There's a column right there. It's available in vCenter, in ESX Top, in VC Ops. Get to know those two numbers, because guess what? High D average equals subsystem problem. High K average equals host problem. Very quick way to diagnose performance issues in the stack. Quick definition of it here. Mark, what are the thresholds? Where do you like to set them? I'll throw it at 1 millisecond for K average, and if you hit 1 millisecond there, that's a problem. You have host contention. There's something we need to look at. And for D average, I set the tipping point at about 15 to 20 milliseconds. And here, if you want something really, really fast, you're going to go below 10. If you got a batch processor in the middle of the night, you don't mind if it takes a little longer potentially. You can go a little higher.
For magnetic disks?
Sorry?
For the spinning disks?
Correct, yep. And like I said, know these two, put them in your back pocket, find out what interfaces your company has to see them, because very, very useful. If you call me, that's going to be the first two pieces of information I'll ask for. So we talked about kind of the host. We talked about the 4 quick dimensions there. And everybody's kind of going, well, where's the rest of the magic? Well, there is no magic sauce today. Out of the box, we provide very simple configuration, very optimized configuration. You pick the right platform to go with it. You connect it the right way. Everything works. Well, let's talk about the guest quickly and make sure that we're focused on putting in the para-virtualized drivers. All right, so VMXNet3 and PvSCSI. They are aware of the virtualization stack. We're doing things more efficiently in them. We're not doing anything magical, but what we're doing is that I/O for less host cost. And that's savings. That's efficiency. That's why those drivers are better. They do support some other features. VMXNet3 does, large receive offload, receive side scaling. But by default, that would be my network driver. A lot of people love the E1000, and there's a potential, again, a very minor set of exceptions for it. But by default, everybody in the crowd hopefully is using this one. So I would like to poll who's using VMXNet3 as a default driver. Excellent. That's pretty good. Love it. Now, PvSCSI is another one of those interesting ones. LSI, LSI parallel, LSI SAS. I got my bus logic mark. I don't really use PvSCSI that much. Very important for your tier 1 workloads. And again, because each I/O is done at less of a host CPU cost, it's about efficiency there. So I'm not a guy, I don't always put this in my default templates. I like to build my tier 1 applications purpose-built, and I'll put in PvSCSI there. But know you should be looking at that and leveraging that. And a couple things people miss in the guests all the time is the OS paging. Everybody goes on a rampage to recollect memory, squash down memory on those VMs. And what they do is they incur operating system paging. Well, that doesn't show up in a vCenter console. Application people don't know to go look for it, and they hurt performance because we've not given that VM enough memory. So pay attention to paging at the guest level as well. And last but not least, this is a vague line, is the application tuned correctly? And lots of them we don't have to worry about, but I'm surprised to find that many, potentially you build a VM that's an 8-way VM, but the application is not tuned to 8 threads. We have not told it to use 8 threads. So little things like that, again, we need to build that bridge to the application owner. This is something that would happen on a hardware platform, regardless of physical virtual, but it seems to kind of get missed in the VMware environments. So very, very simple things like that, make sure we're not missing in the guest with the application. And last but not least, I have to plug vCenter Operations. So who here has touched vCenter Operations and tried it out? A few. Who's bought it? A few hands still up. I would love to see next year this crowd, everybody putting up their hand. Because up until the release of this product, you guys, I made you go in and spend a ton of time in ESX Top. I made you pull a bunch of data via scripts. That was where the best performance information is. Now, vCenter Operations is about alleviating that pain, looking at performance data on scale, and even better yet, making sure that you know what the application was doing before the problem happened. How many times have we had the old, hey, something stopped working Friday, but you don't know what it was, you can't go back in time to find it out. This application has a great ability to trend what was happening. So I encourage you to definitely check out a session here at VMworld on it. Definitely download it and evaluate it, because I use this every day in my performance set of tuning and troubleshooting, to the point where I'll ask my clients to download it the day before I get on the phone with them, and they've probably solved the problem already just by using these interfaces. Extremely powerful. So quickly, in a nutshell, like I said, not a ton of magic sauce, but a very simple recipe. I cover, again, a lot of big clients, and this is the exact checklist that I run through to make sure we get maximum performance out of the platforms. And with that, I'm going to hand it over to Reza here, who's going to talk to some of the data and some of the testing that we've done.
All right. Thank you, Mark. So it was hard to follow up a master speaker, but I'll try and see if I can live up to what Mark has been telling you so far. So I'm going to talk in particular about 4 Tier 1 applications that we have been measuring in the lab. And also, in fact, one of them is results that's published by a partner. Okay, first one I'm going to talk about are high-performance computing applications. These are applications that love to have, let me see if I can get this pointer to work. Oh, here we go. This is hard to see. Okay, they are both computation and memory intensive, and as a result, you want very high CPU counts, and you want to take advantage of the NUMA properties of the hardware you have. For this particular test, we used a couple of different servers, both of them Nehalem EXBest. So these are latest, greatest processors, with a couple of industry standard benchmarks, the SPEC MPI suite and the SPEC OMP suite. With MPI, it has MPI parallel applications. They use a lot of floating point operations, and they're computation intensive. And for those of you who are connoisseurs of this benchmark, we use a medium data set. For the OpenMP spec benchmark, we use a large data set. I wanted to emphasize that these are non-compliant tests. I don't want to end up in spec jail for these benchmarks. If you want to actually compare to other people's results, we have to actually have submitted them. We haven't. These are internal benchmarks that we have used for studying scaling and native to virtual comparisons, but they are the same exact benchmarks that anybody else would use. And the performance metric for all of them is the completion time. So the lower the bar, the better it is. Okay, so first I wanted to talk about VNUMA, tell you what it is, and then show you how we take advantage of it. So your server down here may have NUMA properties. You have 4 NUMA nodes. But before ESX5, vSphere 5, that information was not propagated up. So what you had was that in the guest, in this blue area, you have one physical node. As far as the guest is concerned, the whole software and hardware underneath of it is a single physical node. Although down here, we really have 4 what we call machine nodes. You have a NUMA server down here. So if that data is not passed up to the guest thinks that this whole thing is a single locality, and as a result may put the processes here and use this part of the memory, but down here we have actually mapped that memory to 4 different NUMA nodes. And so this application is experiencing only 25% locality. Everything is running here. The other 75% of the time it has to go to a different node. With vSphere 5, what we do is that we actually tell the guest, hey, there are 4 NUMA nodes down here. We propagate that data up. So then if The OS and the application are aware of NUMA properties and want to take advantage of it, and in your high-performance computing applications they would, then the guest OS and the application will correctly position things to run on the same node, or not if that's what they desire. If, for example, you want high bandwidth rather than the affinity between data and processing. So let me show you some results here with the SPEC MPI benchmark. This is running, so this is a number of processes in the application in the benchmark, and this is native to virtual ratio. So one would say they're running at identical performance. No pictures, sir. Just kidding. Because now I'm committed to these things. No. Okay. So below 1 means virtual is a little slower. Above 1 means they will be native. And if you look at these 16 bars, I counted them. 3 of them are below 96%. And the other 13 are at 96% and above. So we are pretty much matching the performance of native. And scaling-wise, if you go from 4 to 16 processes, I try to come up with a way of making these a little easier to see. So virtual and native of each benchmark are the same color. Virtual is always dashed, and native is solid bar. So you can see the solid bar is actually below virtual. So it's that virtual scales a tad bit better than native for the LAMPS application. Same with red. Actually, for all 4 of them, they track each other, and virtual happens to actually scale a bit better, perhaps because it started at a few percent lower, so it catches up to the same max performance. For the SPEC OMP benchmark, again, the same thing, the number of threads of execution, the ratio, and you can see it's, especially on the high end, it's around 95% for most of them. A couple of them are 90%, and some of them are close to 1. And again, the same thing with scaling. So you see for blue, which is, I think Apple U, virtual is a tad bit better. For the red application, native actually scales a tad bit better, but they all track each other, right? So the purple, the red, the light green. I guess here is one where native actually scales better than virtual by a noticeable amount, but the rest of them is actually tough to tell if there is a difference. The next application I wanted to look at was Exchange. So the Exchange application has a standard benchmark. LoadGen is what everybody runs. We ran LoadGen with the very heavy workload. Okay, this is the heaviest workload that you can run with LoadGen. And we ran 1,000 users per CPU. Microsoft used to have a guideline of run 1,000 users per CPU. They don't quite push that anymore because CPUs have gotten faster, but that's what most everybody does if you look at the results that are published. And the other criterion to look at is that the 95th percentile has to be below 500 milliseconds, which most of the time it is. And again, we ran this on a recent processor, it's a balanced system, what you would expect of a high-end app. So a couple of things here is that with vSphere 5 now, we can go beyond 8 processors. So looking at the number of users that you can support in a 95th percentile, going from, so the 2,000 user test is on a 2 vCPU VM. The 4,000, we have 4 vCPUs, then 8, and then 12 here, which you could then run on vSphere 4.1. And you can see that with the tuning that we have done, the response time is actually improving for vSphere 5. And the CPU utilization is also improving. So we are running more efficiently and with the response times. As I said, Microsoft has guidelines for Exchange. For example, they don't want you to go over 12 CPUs in a single instance. So what do you do if you have a recent server with 16 processors, and now the sweet spot of the market is even becoming 32 cores? So what you would want to do is run multiple of these. So here, for example, what we did was we ran from 1 to 4 four-way VMs. Each VM has 4 vCPUs and is running 4,000 users. And you can see that the response time, even at 16,000 users, is still only 160 milliseconds, well below the 500 that's the cutoff line, right? So it's easily handling all of these. You probably could have gone farther because you can see that the utilization is only 1,000% on 16,000 on a system that has 16 cores. So we could have, there's another 60% headroom left, right? An alternative to Exchange is Zimbra, and by way of disclosure, it's a company that VMware owns now. It's a subsidiary of VMware. And they also have a load gen benchmark that's very similar to Exchange load gen. I'm not going to try and compare the two right now here. There are slight differences in the way you configure them, in all the auxiliary servers that you need, and in the workload that I'm not going to get into that, but it is a very similar workload. Running this, now here we're comparing virtual and native. So running Zimbra with 4 CPUs, so in the case of virtual, we have 4 physical CPUs. We configured the system down to 4 CPUs, and then we have a 4 vCPU VM. So there is no under commitment. We are not running a 4 vCPU VM and then getting some resources on the side. And physical was 4 CPUs. And again, both run 4,000 users. And you can see the latency is identical, and the CPU utilization between native and virtual is a little bit higher on virtual. And the same with 8. Again, pretty much the same latency. And I think this is experimentation error. It actually looks like native had higher utilization. I'm not going to claim that we actually do better than native, but these are pretty much the same number. And the other thing that's interesting is that, again, we ran 4 vCPU VMs. So in this case, we ran 1, 2, 4, 8 VMs. So here we have 32 vCPUs running Zimbra users. And what I find fascinating is that this actually, I don't think I did a good job on the second y-axis with the response times, because it looks like your classic hockey stick curve until you look at the numbers and you see these are very close to each other. So pretty much very little degradation as you go from 1 to 8 VMs, which is your classic consolidation story. Okay, and last but not least, and I think this is the one that really hammers home the message for me, is results from the SAP sales and distribution benchmark. How many of you are familiar with SD benchmark or have heard of it? Wow, very few. Okay, I'm surprised. All right, so what's interesting about this benchmark is that it is an industry standard benchmark. Everybody who runs this has to run the same exact benchmark, and if you guys go out there and look at the SAP SD results page, you see everybody runs them. And it's also a real-world application. You may not have heard of SAP SD, but I won't even embarrass you or myself by asking how many of you have heard of SAP. I think pretty much everybody has. So this is a real-world app with a certified benchmark. And this is results that was published by Fujitsu on their own. We helped them a bit with the tuning, but this is the benchmark that somebody else published. And they published both native and virtual. And these are certified results, and again, not to run afoul of SAP SD police, I have to tell you what certification numbers these had. And with vSphere 5, we used 24 vCPUs. Now, look at the results. This is a table of native and virtual. These are metrics that you have to disclose for SAP. And the graph is basically a reproduction of what's in the table. You can see that the number of users and the number of SAPs were 6% off native. So we are 6% slower on this ERP real-world certified app and benchmark. And the response time and the CPU utilization is about 1% higher. I mean, I don't think I can get better than this, at least not with this application. And to emphasize the point here, we ran 4,600 users with vSphere 5. The highest number for vSphere 4 was 2,000 users. And so this is more than twice as fast as the best we had done with vSphere 4. It's a quick tip of the hat to my colleagues who did all this work, provide the numbers for me. And do you want to talk through those resources?
Yeah, I'll just touch on them for a second.
Yes.
Yeah. So I just want to connect the messages here, which is, I mean, it looked like a lot of technical data. The team here has run a ton of experiments. And the reason we want to make sure that you're seeing this is that it represents a diverse set of workloads. We're not just trying to fix Microsoft Exchange results or anything like that. We're looking at optimizing all applications. So if you go back to the beginning and we look at that easy recipe, we'll look at all the dimensions, we make some very simple design decisions, some simple configuration. These are the kind of results that come out of that. So I want to make sure that you guys are informed that a Tier 1 application can be anything now. I'll proudly stand at the front here and say, I think we have 99.99% viability today for x86 workloads on this platform. Because we continue to demonstrate the differences to physical are so small, they're insignificant now. It takes a team of people to identify it. I think that there's not a lot of tuning that needs to happen on these platforms now. There's no magic knobs or dials. And yet we continue to kind of push those numbers out. And part of it is, we believe, our technology, some of the features we have, and part of it is the processor manufacturers. So know confidently from all this data, from these simple considerations, you should be able to attempt to virtualize anything and have success. And if you don't, there's probably something that's quickly missed, and let us know. Obviously, we want to reach out and have success, but you don't have to re-benchmark everything. We have tens of hundreds of people doing things like that. So we have a ton of data that we can disseminate to you guys, that you guys can bring to the application vendors as you need. So know that a resource like me, like a team like this, is available. Reach out to your local SEs when you need something. Now, the resources is a little light right now. I was hoping to have a few more links published. They're madly trying to get the documentation out the door. But we do have what's new in performance for vSphere 5. Great guide. Lots of you have probably seen it, but if not, download it. And know that for each application that we tend to work with, whether it be SAP, the exchanges and that, if you go to this Business Critical Apps link, this is where we're housing all that information. So go looking for Exchange there. You're going to start to see, again, our vSphere 5 guide for Exchange, the performance results we're publishing. So go to that link for this kind of data. And last but not least, there are a lot of other great performance sessions going on. I think I counted performance as the second most popular word in Paul Maritz's keynote next to cloud. So I'm number 2. I'll take it. But you can see that the team here has many other sessions. And a couple to really call out is that we have the What's New in Performance for vSphere 5 session. Again, some more detail on the exact features. Some great presenters there as well. And if you're kind of really geeky and like some good details, I'll call out Ravi and Krishna's presentation. They, again, dive deep into numbers and statistics and do a great job. And don't forget to pass by the lab. Our team, Joey specifically, has helped put together a great lab to try out. So know that there's all kinds of great performance information here. And then last but not least, before we take some questions, do fill out some feedback. Appreciate that. I do have a couple of questions for the crowd. By show of hands, how far are you guys virtualized? Let's start at, say, 10%. Who's 10% virtualized their company today? Who's 25? 50? 75%? Anybody get to 100? Wow, excellent, excellent. So I hope what this shows in the crowd here, too, is that your peers are doing it and know that it can be done. So any questions? We have a few minutes for questions. You bet. If I can get you to jump up to the mic, it'll just help reiterate it for the crowd. And I know people are going to start jumping, so.
Yeah, if you could step up to the mic there.
Yeah, two just in the aisles. Thank you.
Yes. I just want to ask you what about real-time applications, like, for instance, Microsoft Link Server?
So real-time applications, excellent question. Extremely latency sensitive. We have put a ton of engineering effort into real-time applications. That is a big focus for us. It definitely was with vSphere 5 release. So know that we recognize that almost as a dedicated kind of application set on its own. And we are focused on optimizing all of the stacks for the latency those applications require. We are running real-time SCADA system environments virtualized today successfully. We are running hardcore demanding VoIP applications. I call that real-time today. So yes, absolutely, we do it. Absolutely, if you're having some trouble with it, reach out to your local SE. You should have success.
To add to what Mark said, admittedly, until as far as vSphere 4, our focus was to close that gap to native. And one way you do that is by, for example, coalescing and trying to jam as much as you can. So our focus was a lot on, if you saturate native and you saturate virtual, what the gap is. With vSphere 5, we took a step back and looked at a lot of latency-sensitive applications, where it's not maybe necessarily important that you squeeze that last 5% of utilization of the system, but that you want to have as quick a response by delivering interrupts right away, by scheduling processes right away, even though it may not be quite as efficient and you may lose a few % of efficiency, but you get really fast latency. So that we have done in vSphere 5, like Mark said.
Okay. Two questions, both around vSwitches. First is distributed vSwitch versus just standard vSwitch per host and then using the physical network to link them. When I'm using a distributed vSwitch, it feels like there's a slightly greater latency just on average across everything compared to before and after. And this is using a quad gig link for the VM public network side. And related to that question is the network I/O control. We get different views. On one hand, some presenters keep saying we've never seen anywhere close to saturation. If you're using 2 or 3 load balance links, that's even less of an issue. And on the performance side, you're telling us that, well, you should use it. Am I matching that up with QoS on the hardware switch, or should I go with you never reach saturation anyways, why bother?
So good questions. And I'll let you jump in here, Rez, for a second. I'm not aware of any data that we have that shows any performance difference between the two switch types. Personally, as a VCDX and a designer of many big environments that way, I'm a distributed switch kind of guy. I think that's the model going forward. I'd be interested to follow up with you. Let's touch base after here, because I'd love to see if you found something, because if it is, we want to fix it. That shouldn't be the case. Are you aware of any data? No. Second, the use of network I/O control. When everybody talks and presents, they're kind of talking the law of averages. And I would say 95% of our customers and clients probably aren't saturating many links yet. And so you'll get the old, don't worry about it. Again, kind of from the design principles, we're talking about maximum performance, predictability for Tier 1 applications. That's a technology you want to have in play to help with that, because the environments are dynamic now. So I want to guarantee a service level to an application. Therefore, I need a network I/O control type engine to help support that, to make sure that as my environments are dynamic, vMotion's not hurting anything, storage traffic isn't hurting anything. The consideration for saturation is a tough one, because we need to look at what you're doing. I'll be honest, I rarely see links saturated again in the network. Yes, on servers with 2 10 gig NICs, carrying all the network traffic, all the storage traffic, we can see some pretty good utilization, especially as we're vMotioning. But generally, I don't ever see bandwidth as a constraining factor. Unless, again, we're talking about those last few percents of clients, and in that case, we design around that. We make sure we're breaking it out or we're aggregating correctly. But the network I/O control stack helps make sure your application isn't hurt during that process, or if you haven't discovered that. So I know it's kind of a little bit of a wash answer there. It depends on what you're attempting to do in the design, but no, again, I say bandwidth is rarely a problem. Use the technology to make sure you're okay. And when it's not working, reach out to your local team, because people like me can come in and help tune or look at that stuff with you. Sir.
There are 16 gig, 24 gig VMs, and you have DRS set up. It'll be vMotioning them around. So for performance, how should you configure that?
So is the question kind of scale and configuration as I build bigger VMs?
And how aggressive should your DRS rule be set up to move things around, and what kind of vMotion network should you have for such a thing?
So I'll kind of come back to the first layer, which is always, let's look at it simplistically. If you're going to build big VMs, we want to make sure we have big bandwidth between all the hosts that we're going to use. And so as soon as I kind of scale past the 16 gig markers, kind of my preference, I need to make sure we got some good vMotion networks in place. I don't really consider DRS in that equation, because during vMotion, even though we're copying those last of the memory pages across that way, performance is almost immeasurably impacted while the process is occurring and just at the moment where we kick over to the other side. So performance-wise, we don't see a ton of impact on your average workloads. Now, if you have a terabyte database system you're vMotioning, I would anticipate probably a little bit of performance implication. Now, I don't even think we have test data on that, because nobody's built anything that big yet. So my guidance would be, make sure you got enough bandwidth, but don't be afraid to build the right size VM. DRS will handle things right, the simple design will handle things right, and the performance impact should be very, very, almost immeasurable. Did that help?
Should you expect a few more pings lost? Like I'm mainly virtualizing SQL servers, so they are large. So I notice I'll lose more pings sometimes. Is that to be expected?
That you lose a ping?
And what bandwidth should that vMotion network be?
So
give me some ballpark figure.
Yeah, so ballpark today, your vMotion network should be gig. I don't see why anybody doesn't have at least gig today. But if you're looking again towards big VMs, bigger than 16 gig, I'm a fan of having 10 gig available.
Yeah. That's
for that.
In the lab when we deal with large VMs doing, I think I heard you say SQL Server? Yeah. We do vMotion experiments with other databases while they're doing huge amounts of I/O with large memory, and we use 10 gig. I mean, if you're serious about a big VM with lots of vCPUs and large memory, and you don't want things to back up, you got to use 10 gig. At least one.
Sorry, to the drop ping too. Yes, can we potentially lose a packet along the way? Keep in mind that's not a virtualization performance penalty that incurred that. The switch tables actually have to update themselves because the workload has moved. So it's not uncommon to potentially see that as you run a vMotion. Now keep in mind, most applications today built in the last 5 years could probably sustain anywhere from a 30 to 60 second network disconnect before the client would ever drop what it was doing. And again, a generality, yes, but know that we see that kind of resiliency today, so that drop ping is outside of the stack. That's a physical network topology update that causes that.
So if you come to my second time this afternoon, so to warn you, I'm probably going to use half of these slides, but have a different spin on them. One of them is I show results from doing a vMotion with Exchange. And like Mark said, you can see that one of the measures that Exchange, that LoadGen has, is how many transactions got queued up. When you normally run this with these fast processors, today's systems, you have none. But when you do a vMotion, you see that, you're running 12,000 users, you have a few hundred that did get queued up at some point. What number of transactions that were backed out or were lost? right? So you do take a quick hiccup, but as Mark said, applications are set up to deal with it, and you continue.
Thanks.
You bet.
You talked about using full reservations. Like if I have a 16 gig SQL server, you're talking about giving it 16 gig off the bat. What if he's only using 8 of the gig most of the time, and of course once you give him 16, you can't ever take back 8. Would it be better just to give it 8 then?
So, question being a good one here. If I size a VM to 16, I figure he's only using 8 some of the time. Should I just reserve that 8 instead of the 16 gig? For a database workload, I'd say reserve the 16. Because the operating systems and database services today are using the extra memory for cache to do other activities. And they're dynamically changing those values in there. But if we don't give them that, and we take it away potentially, and you haven't reserved it, that can impact performance. And worse yet, it makes it unpredictable then, because we don't know when that's going to occur and when not. And so that's why my recommendation would be reserve the full amount for your most important workloads. I'm not saying every database is your most important workload, but those that are, put the reservation in place. The other part too is there's not a great set of tools to identify what is actually being used. That's a science to figure out how much of that memory is actually being used. So err on the side of caution, tier 1 performance predictability, use a reservation for the full amount.
CPU and memory?
Sorry?
CPU and memory?
I'm memory, CPU, I love let the scheduler do the work for you, but memory, yes. Yeah.
Yep.
Great session, Mark.
Thank
Really,
you.
Enjoyed it. I had a question, though, on I think it was the Zimbra portion. It mentioned that hyper-threading was turned off, but in your opening slide, you said leave hyper-threading on. So I'd just like to ask you about that.
Okay, I think I heard you say you were wondering why we had hyper-threading off for some of the tests and on for other ones. Is that the question?
That's correct, yeah.
It was a question of how much resources we needed for that. Hyper-threading be handled like anything else, and depending on your application, you get anywhere between 5 to even 35-40%. And if that's in your application, you get it on vSphere just the same. It was just a question of how many vCPUs we thought we needed, and how many physical CPUs we thought we needed to present to the system for that particular test. So some of them had it, some of them didn't.
So more an artifact of the test than there was something there that didn't perform correctly. 5 more? Gotcha. Thank you.
A question about reservation and assigning SQL VMs potentially more memory than they needed, and the risk of ballooning.
Sorry, I didn't quite catch
the
last
risk
one.
of having ballooning.
What's the risk of having too much memory?
Right.
So in my mind, there's no risk. If you can afford the memory and we can allocate it to a machine, that's to its advantage. All applications are really written nowadays to leverage what's available to them. So having gone through sizing activities, there's kind of your figure that comes out. But if you want to give it a little more, no risk. No performance concern or penalties or worries like that at all. In my mind, the risk is undersizing or taking back too much. And even some of our tools are guilty of that. Capacity IQ, for instance, is looking at active pages touched. It doesn't really take into account necessarily file system caches, read-only system caches that those VMs are using. So always balance what the workload is doing with the data you have on hand to make an intelligent decision. But that would be the downside. There's definitely no downside to over-allocating other than you're out of memory. And you're going to go into, as long as you're not swapping, TPS, ballooning, compression, those are all okay things.
Right.
That's a good point. So just to reiterate for anybody in the room that didn't hear, the concern with SQL Server installation today is using up all the memory, not reserving enough for the OS. How do we balance that out? We didn't touch on it on any of the slides, but in the practice guides that we'll publish for those things, we're obviously noting stuff like that. And first and foremost, the rule is however you would do it on a physical server is how you do it on virtual hardware. So if the practice is on a physical box to reserve OS memory, we're still going to do that. So none of our rules should supersede the practices in industry today. We continue to leverage those. That's a smart thing to do. Good point.
So virtualization does not obviate the need for good tuning. It actually, one has to admit, it does add one more layer. So now you have to tune one more thing. But all the things you had to do for your, how to make sure that your min and max memory of SQL Server are set right, and how to make sure you use large pages properly, all of those things apply here too. Yes.
So on the question of memory reservations, right now our practices are that say SQL is actually hard set through config to use 24 gigs of memory. I would say, okay, well, I want Windows to stay within the 75% so it never pages. Let's say that puts me up to 28. I allocate 32 to the VM, but I only put in reservation for 28 with the assumption that the last 6 will never be used. I don't want to reserve it. SQL will never be allowed to use that much because it's by config. Does that generally fit in with because on the assumption that, hey, I'm not going to reserve what I will not allow the application to use?
So, good question. My thought process is I think you made it overly complex. In that case, you did some good math. It makes sense. I would agree with the assumptions that way. But in that case, that you're hedging your bet, you're adding a little more. It's probably not going to be used. Let's just size it one way, make it predictable, and again, not leave that flexibility in there for something to happen that becomes unpredictable. Especially in the database worlds, all of a sudden, the database wants to use that memory. It's available to the OS. The OS starts to hand it out. But because we didn't reserve it, we've gone and paged it out to somebody else. Again, unpredictable performance. And so for your most important, again, it's all about deterministic. So I wouldn't leave anything to chance. I would more decide, again, if this is what SQL needs and this is what the OS needs, you add the two of them together, set that up as your configuration and set that up as your reservation.
Yeah, because this config came from Microsoft, where the default setting of the OS is that once in-use memory is past 75% of what the OS sees, it starts considering using the page file that you configured. And I really don't want to do that, so hence the over-allocation of memory, not so that I think it's needed, but to, let's say, compensate for Microsoft's problem where it thinks anything over 75 is actually not good and start looking at page files. So even though it has more memory, it'll still try to go to page file anyways. So
here's that risk of over-allocation. I'd rather not even try to get into that situation. I'd oversize that SQL instance, give it some more memory, and it kind of balance that out. Now, I'm definitely not the SQL guru, so some of the immediate SQL practices, I know we have a couple other SQL sessions, and worst case, reach out to me here and I'll get your question answered a little bit more directly. But from the high-level perspective, I wouldn't get into balancing that in the OS and then handing some of that balance off to the hypervisor. Just cut and dried, simple reservation.
I'll take one last quick question.
Okay, from a time to recovery aspect, in the event of hardware failures on instance backup for these types of applications, do you normally use admissions control with like a percent-based policy in a cluster, or would you be looking at a dedicated failover host in terms of getting it up quicker?
Great question. I think that really comes down to the SLA you need to meet and the economics of what you have to spend around that. So I have seen designs go both ways that way. I would, again, really take apart how you need to recover and what that cost is going to be to balance that. Obviously, available capacity is a great situation. I mean, admission control is just making sure that you have that capacity available in your environment somewhere. Is there a difference between bringing it up on some populated host versus bringing it up on an empty host? Not at all. There'd be no performance implication to that. You just want to make sure that it's available in some form. Well, great. I know we got the hook here, but I'll hover by the door for a few if anybody has some other questions they want to bounce off us. Thank you all very much.
Thanks for good questions.